Good morning, everyone. This is Dr. S. Mitthra, reader from the Department of Conservative Dentistry and Endodontics, Sri Balaji Dental College and Hospital, by her University, Bharat Institute of Higher Education and Research. So I'm here to present a topic today on rotary instruments used in operative dentistry. The contents of my presentation is going to be introduction. What are the characteristics of rotary instruments? What are the different types of handpieces that are used? And what are burs, and a final conclusion. So the term rotary instruments in dentistry refers to a group of instruments that turn around an axis and perform any function such as cutting, upgrading, burnishing, finishing, polishing of the tooth structure or the restoration. So the characteristics of rotary instruments can be listed under speed, pressure, heat production, vibration, patient reaction, operator fatigue, sources of power, and instrument design. So we'll see one by one into detail. The first parameter is the speed. The speed refers to the RPM, which is otherwise the rotational speed of the instruments. So RPM also refers to revolutions per minute or rotations per minute. So depending upon the speed ranges, there are various classifications. So the first classification was given by Studeman. So according to Studeman's classification, low or slow speed handpieces which have a speed range of less than 12,000 RPM, medium or intermediate speeds which have around 12,000 to 2 lakh RPM, high or ultra high speed which are greater than 2 lakh RPM. Another classification given from textbook of operative dentistry by Marzuk, ultra low speed which is around 300 to 3000 RPM, low speed is 3000 to 6000 RPM, medium high speed is around 20,000 to 45,000 RPM, high speed is around 45,000 to 1 lakh RPM, ultra high speed is around 1 lakh RPM or more. So depending upon the different types of speeds, we can classify the handpieces based upon the particular uses for the intended speed. So low speed handpieces are mainly used for oral prophylaxis procedures and also for finishing and polishing of various restorations. Here, the cutting is ineffective. It is time consuming. Lot of force has to be applied while cutting with the handpiece. Hence, lot of vibrations are produced which are of a high frequency and high amplitude. So the medium speed handpieces can be used for cavity operation and for finishing and polishing procedures and for placement of retentive grooves and bevels. Whereas the high or the ultra high speed handpieces are the ones which are commonly used in day-to-day clinical practice and mainly for tooth preparations and removal of old restorations. The advantages is that they have faster removal of tooth structure, they have less pressure, they have less vibration, and the heat generated is also less. The operator has better control and there is ease of operation. The instrument lasts longer as the vibrations produced are less and the operating time is also reduced. Coming to the next parameter, which is pressure. So pressure is related to force and surface area. So the formula is pressure is equal to force divided by surface area. Low speed handpieces require a very high pressure, which is around 2 to 5 ounce, and high speed handpieces require a still less pressure, which is only 1 pound. Whereas ultra high speed handpieces require very, very minimal force, which is only 1 to 4 ounce. High speed, ultra high speed handpieces and high speed handpieces are held very light touch like a feather. The next parameter is heat production. So heat is directly proportional to the pressure, RPM, area of the cutting tool in contact with the tooth structure, and permanent damage to the pulp can result if the heat production reaches around 130 degrees Fahrenheit. So greater the pressure, greater the RPM, greater the area of cutting tool in contact with the tooth structure, greater is the heat that is produced. Hence, all these three parameters must be minimized. Vibration is a product of the equipment used and the speed of rotations. So hence, we have to minimize the deleterious effects of vibrations. So the deleterious effects of vibrations are of two-fold in origin, which can be in the form of amplitude and undesirable modulating frequencies. The next parameter is patient's reaction. Factors that cause tension or apprehension on part of the patient is heat production, vibration sensation, length of the operation time, and number of visits. Hence, The following 4 parameters, the heat production must be minimized, the vibration sensations must also be minimized, and the length of the operating time must also be minimized. The number of visits must also be reduced. When all these factors are reduced, there is better patient cooperation. The use of coolants, intermittent applications of of the particular cutting tool to the tooth structure, and avoiding use of any sharp instruments, and bringing these sharp instruments directly in front of the patient's eyes can also be minimized. Any restorations that cause unnecessary irritation to the oral structures must also be avoided. All these factors will help the clinician or the doctor to generate better patient comfort. Next is operator fatigue. The major factors that cause fatigue on the side from the operator side or the clinician side are the duration of operation, the vibrations that is produced in the handpiece, and the forces needed to control and apprehension on part of the dentist, and lack of patient's cooperation. Hence, the duration of operation must be minimized. There must be a less amount of vibrations that is produced. Less forces must be exerted to control the handpiece, and the apprehension on side of the dentist must be minimized or must be completely eliminated. And patient cooperation must be 100%. Hence, these factors must be reduced to reduce the operator fatigue. Next is the instrument design. So instrument design will go into detail about 2 parameters. We'll see in detail about handpiece and the cutting tool, which is nothing but the dental burrs or dental stones. So coming to the definition of a handpiece, which is a very important Viva question and 2-mark question. A handpiece is a device for holding rotating instruments, transferring power to them, and positioning them interorally. So depending upon, there are various classifications of handpiece. So depending upon the angulations, we have straight, contra angle, and right angle handpiece. And depending upon the speed ranges, we have low or slow speed, medium or intermediate speed, high or ultra high speed. And depending upon the driving mechanism, we have gear driven, water driven, air driven, and belt driven. Coming to the parts of the handpiece, any dental handpiece has got the 3 common parts. First is the head of the handpiece that holds the cutting instrument. In this case, it is your burr or your polishing stone. And next is the handle or the shank of the handpiece, where the clinician or the dentist holds the handpiece. And this part is a connecting end where the handpiece is connected to the source of power. Coming to the shank design, there are 3 common instrument shank designs. It can be a straight handpiece, or it can be a latched handpiece, or it can be a friction grip handpiece. The neck design, the neck is the intermediate portion of the instrument that connects the head to the shank. So the main function of the neck is to transmit the rotational and translation forces onto the head. So the head is a major part of the instrument, which is a working part of the instrument. The burr or the abrasive stone is held in position interorally with the help of the head. Coming to the basic criteria to be evaluated in using a handpiece. First is a friction. So any moving part of the handpiece is going to generate any friction when it comes in contact with the tooth structure. Hence, the friction must be minimized so as to minimize the amount of heat that is produced as a result of friction. If the heat that is generated from friction is not prevented, the handpiece will become unsuitable for clinical use. Another important Viva question is about torque. Torque is the ability of the handpiece to withstand lateral pressure on the revolving tool without decreasing the speed or the cutting efficiency. The torque depends upon the type of the bearing used, the amount of energy applied to the handpiece. Coming to the vibration, vibrations are a deleterious part of rotary instruments, hence unnecessary vibration must be avoided in order to avoid the excessive wear of the turbine bearings. Coming to the dental burrs. So the dental burrs can be classified first according to the material used. There can be a tungsten carbide burr, wherein the tungsten carbide blades are cut onto the steel shank. Can be a steel burr, wherein the diamond abrasive particles are impregnated onto the steel shank, or it can be a combination of the above. Depending upon the mode of attachment to the handpiece, the burrs can be of latched type or a friction grip type. Depending upon the direction of rotation, it can be a right burr or it can be a left burr. Depending upon the length of the head, it can be short, long, or regular. Then according to the use, it can be a cutting burr or it can be used for finishing and polishing. Depending upon the shapes, we have round burr, which is used to give a punch cut for the initial tooth preparation. Can be inverted cone burr, which is commonly used for class 1 and class 2 amalgam cavity preparations, so as to obtain the walls converging towards the opposite surface. A pear-shaped burr, wherein the walls of the burr are tapering towards the tip. A straight fissure burr, wherein the walls of the burr are parallel towards the tip. And this is a tapered fissure burr, a tungsten carbide burr, and a round wheel burr, which is most commonly used to place grooves for gross removal of the tooth structure. Crosscut cylindrical fissure burr, wherein the crosscuts are impregnated onto the tungsten carbide blades. This is to increase the cutting efficiency and the cutting effectiveness. Crosscut tapered fissure burr and end cutting burr. End cutting burr, wherein only the end of the burr cuts, and this is most commonly used to establish the finish line in crown preparations. Coming to the common design characteristics of dental burrs, any dental burr has got the following three basic parts: the head of the burr, which is the cutting end of the burr, and the neck and the shank. So the neck is that part of the burr that joins the head and the shank. Coming to the design of the dental burr, which is an important short-term and exam-oriented question. So first we see what are flutes. The burr head consists of uniformly spaced blades with depressed areas in between. So these depressed areas in between are called as flutes. Coming to the rake face. The rake face is the surface of the burr blade on the leading edge. The clearance face is the surface of the burr blade on the trailing edge. The rake angle is the angle that is formed between the rake face and the radial line. The clearance angle is the angle that is formed between the clearance face and the work. The blade angle is the angle that is formed between the clearance face and the rake face. So this is a picture showing a cross-sectional design of a dental burr, wherein we can see the burr tooths in contact with the work, meaning the tooth structure. So any burr tooth has got a rake face which is on the leading end, and this is the clearance face which is on the trailing end. So the angle that is formed between the rake face and the clearance face is called as a blade angle. Another line is a radial line, which is drawn from the center of the burr tooth to the center of the land area. The land area is placed in the center of the burr, which is used to support the burr tooths. So the angle that is formed between the rake face and the radial line is called as the rake angle. Now the angle that is formed between the clearance face and the work is called as the clearance angle. So the land area is a plane surface immediately following the cutting edge. The cross cuts are the notches that are made on the tungsten carbide burr in order to increase the cutting effectiveness. So coming to the factors influencing the cutting efficiency of burr, we have influence of design and manufacturing. The first parameter is the rake angle. Rake angle, as I've already explained, is the angle that is formed between the rake face and the radial line. So the rake angle can be of three types. It can be zero, it can be positive, it can be negative. When the rake face and the radial line coincide with each other, it is a zero rake angle. When the rake face lies outside the radial line, making an obtuse angle, it is called as a positive rake angle. When the rake face is inside the radial line, making an acute angle, it is called as a negative rake angle. A positive rake angle is important because it gives greater cutting efficiency for any dental burr. The clearance angle is the angle at the back of the tooth and the work. That is, the angle that is formed between the trailing end and the work. So this provides clearance between the work and the cutting edge and prevents any debris from clogging on. The blade angle is the angle that is formed between the rake face and the clearance face. So increasing the blade angle reinforces the cutting edge and reduces the chances of the breakage of the blades. Carbide burrs are brittle, hence require greater blade angle in order to minimize the fracture. Number of teeth, blades and their distribution. So the number of blades in an excavating dental burr is usually around 6 to 8. But however, in a finishing burr, it is increased to 12 to 40. The greater the number of blades, the smoother is the cutting action. Runout. It is a dynamic test used to measure the accuracy with which the instrument is being rotated. The average clinical value of the acceptable runout is 0.023 millimeter. Any burr is going to rotate around a center or a common axis of rotation. So the first circle indicates the 0.025 or 0.023 millimeter. So any dental burr has to rotate around this first circle. If the dental burr is rotating in the outer circle, that means the burr has gone into a runout. Hence, the handpiece has to be replaced or it must be sent for repair. Concentricity is a direct measure of the symmetry of the burr head. So heat treatment is used to harden any burr that is made up of soft steel. So this is not required for tungsten carbide burrs. The design of the flute ends. So the dental burrs have two different styles of flute ends, wherein the star cut and the revelation cut. In the star cut, the flute ends come together and a common junction at the center of the axis of the burr at the tip of the burr. If the flutes come together at two junctions near a diametrical cutting edge, then it is referred to as a revelation cut. Neck diameter. A neck that is too small in diameter will result when an instrument is unable to resist the lateral forces. Depth of engagement. As the depth of engagement is decreased, the force intensity on each small portion of the burr is also increased. Spiral angle. Burr with a smaller spiral angle are preferred when compared to high speeds, as small angles produce more efficient cutting. Cross cuts, they produce roughness on the tooth surfaces. However, they increase the cutting efficiency of burrs. Influence of load. As already explained, low-speed handpieces require a higher load that has to be generated so as to produce the cutting of the burr, whereas high-speed and ultra-high-speed handpieces require a minimum force to be exerted. The minimum and maximum loads for a low-speed handpiece range around 1000 to 1500 grams, whereas the minimum and maximum loads for a high-speed handpiece is around 60 to 120 grams. Influence of speed. The higher the speed, the better the cutting effectiveness. Hence, high or ultra-high speed handpieces exhibit a better cutting efficiency when compared to low-speed handpieces. Hereby, I conclude saying that rotary instruments are most universally used for gross removal of tooth structure. There is continuous evolution of handpieces and dental burrs, and they have become more efficient, more user and more patient-friendly with the introduction of faster and more effective new burrs and new handpieces. Considering the technological advances and the latest generation of burrs and handpiece, the clinician or the doctor can select which type of handpiece and whichever particular type of burr that is best suited for the particular clinical treatment that needs to be performed in day-to-day clinical practice. These are my reference textbooks. Textbook of Operative Dentistry by Marzuk. This is the cover page of the textbook. Art and Science of Operative Dentistry by Studevant, 4th edition. Textbook of Operative Dentistry by Dr. Vimal K. Sikri. Hence, I recommend these textbooks for studying this particular chapter. Thank you for your patient listening. Have a great day.